Okay, ladies and gentlemen, welcome back to Mr. Lee physics class. So today we will learn about the capacitance. So from here, we look at the slide. The slide show that there is a ceiling fan. The ceiling fan is turning. Actually, inside the ceiling fan, the circuit here, somewhere here, there will be a capacitor. The capacitor, what is the function of the capacitor? Let's go to that's we will learn in today's lesson. In this lesson, you will learn to the objective one, deduce and understand the phase relationship between current and voltage for capacitor. Objective 2, define and deduce the reactance of capacitor. Objective 3, understand the variation of power with time. And objective 4, understand the capacitor as a non-dissipative device. So today we'll focus on the first 4 objectives. Ladies and gentlemen, let's look at the slide. The slide shows that an AC generator is connected to a capacitor where a 0 center ammeter and 0 center voltmeter is connected parallel and also series to the capacitor. Let's observe what will happen when the switch is on. So we notice that when the current is 0, the voltage will be maximum. That's we learned before when the fully charged, when fully, the capacitor is fully charged, that means that the potential difference will be maximum and the current will stop flow in the circuit. This is what we learned in the semester 2. Chapter 2. So this is the general characteristic of the capacitor. When fully charged, no current flow through the capacitor. But when there will be if the capacitor without any charge, the current flow through will be maximum. And we notice that means that this current and the voltage, what is the phase difference? The phase difference will be pi over 2. Next, we notice that the derivation of expression for current in the capacitor. The expression for voltage, if the voltage across a capacitor is V equal to V0 sin omega t, then the current I is given by I equal to dq over dt, the current rate of the charge flow. Substitute CV for Q. Because for the capacitor, the charge stop will be equal to CV. Amount of the charge can store in the capacitor will be equal to CV. So we substitute into the formula I equal to dq over dt. This means I equal to d CV over dt. Then substitute the V0, V now, V is general, right? Now, if the V is for the alternating current, so V0 equal to V equal to V0 sin omega t. So see, V0, we take it up. Okay, so this will be Q, right? So that means that we need 2 times with sin omega t. Once differentiate, it becomes cos omega t. The current, okay, after differentiate, it becomes cos omega t. Okay, and the omega, take it up one more. Okay, so this means I equal to omega C V naught cos omega t. So this means that the current, when the current is sin omega t, that means, sorry, when the voltage is sin omega t, voltage, the current will be cos omega t. Substitute I naught, that means I equal to I naught cos omega t, where the I naught is the peak current, V naught is the peak voltage. Next, what happened to the V and I graph? We notice that when the current, blue color represent the current. When the current is maximum, the voltage is minimum. When the voltage is maximum, the current will be zero. Once the voltage is zero, the current maximum. This means they always have a phase difference. Now we notice that for the capacitor, for a capacitor, if V equal to V naught sin omega t, then I will be I naught cos omega t. Where I equal to I naught cos omega t equal to I naught sin omega t plus pi over 2. That means that pi over 2 will be the phase difference, where the phase of V equal to omega t radian. Okay. So from here, phase of I will be omega t plus pi over 2 radian. Then from the phase difference between I and V, because the phase difference for the V is omega t, current is omega t plus pi over 2. That means that the phase difference between I and V, between the current and the voltage, will be pi over 2 radian. So since the phase I greater, phase I is greater than the V. Okay, I is greater than the V, so the current leads voltage by pi over 2. Okay, so yesterday, that is the voltage lead the current, right? Yesterday, in the inductor, voltage lead current. In the capacitor, current lead voltage. Easiest how to remember. Capacitor used to store charge. We need to have a current so that we just can store the charge. So we must have the current first. Okay. Once we have the current, that means that the current leads the voltage by pi over 2. So now, as a summary, if the voltage across a capacitor is V equal to V naught sin omega t, then the current through it will be I equal to I naught cos omega t, where the phase difference between I and V is pi over 2 radian. And last, current lead the potential difference by pi over 2 radian. Ladies and gentlemen, let's observe the next slide. The next slide shows that a capacitor is connected to an AC generator. When the AC generator is switched on, now we want to see the current flow in the circuit varies with the frequency. Once the frequency increase, the current also increase. So that's why our alternating current in Asia, we use 240 watt, 50 hertz. But in US, they use 110 watt alternating current with 60 hertz. Why? Because once they use higher frequency, current will be higher. So voltage no need so high. But for ours, we use high voltage, low current. Okay. So now next, you must remember that in a capacitor, the current flow is directly proportional to the frequency. Now, what are the difference between the current varies the separation. Current varies the capacitance. So when the switch is on, we notice that. When the distance between the two plates in the capacitor or of a capacitor reduce, that means that the current flow increase. When the capacitance increase, the current also increase. Current is directly proportional to C, but the current in the circuit is inversely proportional to the separation of the capacitor plate. Reactance of a capacitor is a measure of the opposition of the flow of current by the capacitor in AC circuit. Opposition, that means that reactance. So reactance XC, the concept same with the resistor. Why? Because the SI unit is on. So reactance SC of the capacitor is defined as peak voltage across the capacitor over the peak current through the capacitor. XC is equal to V0 over I0, where V0 over I0 is equal to omega C V0. So this means that the V0 and V0 cancel at the end 1 over omega C, or XC, the reactance, is equal to 1 over 2 pi FC. Ladies and gentlemen, let's look at the graph. The reactance now, the graph shows that reactance against the frequency, reactance against the capacitance. From here, we notice that reactance is inversely proportional to F, reactance is inversely proportional to C. So they should have the same pattern of the graph. Okay, because the frequency is inversely proportional to XC, frequency inversely proportional to the reactance. Capacitance also inversely proportional to the reactance. Okay, so now the reactance R does not depend on the frequency F. Reactance, we look at the graph. Okay, so from here, we look at here. The reactance, we notice that resistance is not depends on the frequency. Resistance is the resistance of a resistor. Resistor, that means that the resistance is not depends on the frequency, but the reactance of an inductor is directly proportional to a inductor. The reactance of a capacitor is inversely proportional to the frequency. So this means that in the resistor we learned before, R is constant. For the XL, the reactance of a inductor, the reactance XL is directly proportional to the frequency. But for a capacitance, for a capacitor, the reactance is inversely proportional to the frequency of the alternating current. What happens when we have two capacitors which connected series to each other? Series to each other, this means that the total capacitance will be, the effective capacitance will be 1 over CE, effective here, total, will be equal to 1 over 30 plus 1 over 60. So at the end, we get that it will be 20 microfarad. Okay, this means that the capacitance reduced. Once the reactance of the capacitor XC is equal to 1 over 2 pi FCE. So now we use that, we replace the effective into the formula, effective capacitance into the formula, we get that it will be 159 ohm, where the current is equal to V over XC. If we use IRMS, that means VRMS over XC. Okay, so if we use peak voltage, this means that we need to use the I peak I naught equal to V naught over XC. So still we get 1.45 ohm, 1.45 ampere. So the peak current, this means that from here we wish to find the peak current. So IRMS times with square root of 2, we get 2.05 ampere of the current flow in the circuit. That is an example. Ladies and gentlemen, as a conclusion, reactance of a capacitor is a measure of the opposition of the flow of the current by the capacitor in an AC circuit, where XC is equal to V naught over I naught. That means that reactance equal to peak voltage over peak current. Reactance also equal to 1 over 2 pi FC, where the F is the frequency of the alternating current and the C will be the effective capacitance in the circuit. And last, the SI unit for reactance is equal to ohms. Easiest reactance, the concept similar the resistance of a capacitor. Ladies and gentlemen, let's look at the next slide. The variation of the electric field strength, because the capacitor considered is formed by a two plate. This means that when charging, what happened? So when they are maximum charge, this means charging, right? Okay, until discharging. So this one charging with opposite terminal, look at the difference A and C. If at C, left side is negative, right side is positive, right? So if at A, this means that opposite terminal. Then discharge, charging, and discharge. Okay, so the process of the charging and discharging. When positive, this means that A and C. One is the positive maximum, another is negative maximum. So that means that the difference are the terminal of the plate. That means that it will show that there will be the difference of the direction of the electric field between the two plates in a capacitor. Derivation of the expression for instantaneous power, where P is equal to IV, right? So when V equal to V naught sin omega T, the I will be I naught cos omega T, because the phase difference is pi over 2. Pi over 2, one is sin, one is cos. So from here, hence the instantaneous power P supplied to the capacitor at time T is given by P equal to IV. Replace the I naught cos omega T, V naught sin omega T into the formula. So instantaneous power, this means power at any position, P is equal to I 1 over 2 V naught I naught sin 2 omega T. Now observe the variation when the current shown by the red color, voltage shown by the blue color, and the green color show the power. When P equal to IV, maximum and 0, 0. Here, half and a half, okay, somewhere that will be maximum. So the maximum will be somewhere here. So as this will be the variation of power with time, variation of current with time, and the variation of the potential difference with time in combined in the same X and Y axis. Now, what is the meaning of the area under the graph of the power? So here, P means that this will be positive, negative, positive, negative. Okay, so from here, P positive, P negative. Okay, that means that the area, the power supplied to the capacitor. Okay, P means that power supplied to the capacitor, okay, will be in, let's say, left side positive, right side negative. And negative means that they still with the same power supply, but in opposite direction, opposite terminal. The terminal exchange each other. Okay. As a conclusion, we can say that the instantaneous power P supplied to the capacitor is given by P equal to 1 over 2 V naught I naught sin 2 omega T. A pure capacitor does not dissipate energy. Ladies and gentlemen, these are the concepts of the reactance in a capacitor. So here come to the end of today's lesson. Ladies and gentlemen, later, as usual, I will post the question to our Telegram group. So I hope I wish my student solve the question first before check the answer. Ladies and gentlemen, this other question. So question number 1, question number 2, question number 3, question number 4, question number 5, question number 6, question number 7, and solve until the question number 8 only. Question number 9, 10, 11, 9, 10, okay, 9 and 10, no need to solve it because the question, okay, already the syllabus already, this question already out of our syllabus. Okay, previous syllabus we still have, but now it already take out from our syllabus. So this means that solve the question 1 to 8 only. So thank you, my student, and we continue again on next lesson.